Hey, it's Joshua, room 13. The last few rooms were about systems talking to each other, right here in one place. This room steps all the way back and looks at the whole planet. Because your users are not in one city, they are everywhere at once. And the thing standing between them and your service is the one opponent you can never argue with: distance.
Your library sits in Virginia. Your reader sits in Tokyo. Every question they ask must cross an entire ocean, and every answer must cross all the way back. And here is the part that stings. There is nothing wrong with your system. The data is perfect. The servers are quick. The shelves are in flawless order. The problem is not the library. The problem is the distance. The request itself is swimming halfway around the world and back for every single page. And you cannot out-engineer the speed of light. No faster server, no cleverer code will ever shorten that ocean. So this room asks a brand new question. Not how fast is your library, but how close is it? Close to whom? And the answer will force the library to exist in 100 cities at the very same time. So you do the obvious human thing. You open a small branch in Tokyo, and another in Berlin, and one more in São Paulo. Each one stocks copies of the most asked for books, right there in the neighborhood. Now, the Tokyo reader walks to the branch down the street, not across the sea. The popular books are already on the shelf next door. The ocean only gets crossed when something is missing. But look closely at what you just signed up for. Again, every branch is another copy of the truth, and every copy can drift from the original back in Virginia. You have not escaped the cache's old bet. You have made it 100 times over in 100 towns. The same promise of speed, paid for with the same risk of serving something a little stale. A book is corrected in Virginia, but the branch in Berlin is still handing out last week's edition. Fast and close, bought with the very same currency as always: freshness. That network of neighborhood branches has a name: a content delivery network, a CDN. The branches themselves are called edge locations, little caches scattered close to where people actually live. The reader's request stops at the nearest one, instead of crossing the ocean. A hit at that branch, and the answer is already next door, almost instant. A miss, and that one branch makes the long trip back to the original, the origin, just once. Then it stocks the copy, so the next neighbor never has to wait. Same cart, the same hit, the same miss, the same TTL you know from the cache room, just pushed all the way out to the very edge of the map. Here's the keeper. Latency is distance. The cheapest speed up in the world is not a faster machine. It is a shorter trip. Move the copy to the reader instead of dragging the reader all the way to the copy. You cannot beat the speed of light, so you stop fighting it. You stop making the request travel, and you simply leave the answer waiting next door. The labels are the stickers. The network is a CDN. Its branches are edge locations. The original is the origin. In the cloud, that branch network is CloudFront, and the cousin move, sending each reader to the whole library that answers fastest, not the nearest copy, is Route 53 latency routing. And the old fork comes back, now wearing a map. Content that is the same for everyone and rarely changes. Your images, your video, the marketing page, caches beautifully at the edge. One copy serves a whole city, and a little staleness barely matters. But content that is unique to one person and must be correct to the second, a bank balance, a private feed, barely caches at all. It fails the bet twice over. No neighbor to share it with, and no patience for stale. The edge loves the shared, the stable, the read many. So the exam just shows you the symptom. Global users, slow to load your images and video, and you must cut the latency. That is CloudFront. Push the copies out to the edge. Route every user to the region that answers them fastest. That is Route 53 latency routing. But a game, a voice call, a fixed IP address, that is Global Accelerator. And the distractor to refuse? Per user must be fresh financial data served from a CDN. That is exactly what the edge cannot cache.
Your turn. Out loud or just in your head. I'll wait. You are serving a global audience two very different things. A viral news article that millions are reading this very minute, and each logged-in user's personal account balance. One of them belongs out on the edge branches, the other does not. Which is which, and what disqualifies the one that has to stay home?
The news article goes onto every branch. It is shared by millions, nearly identical for all of them, and a few seconds stale is completely fine. The cash bet pays off enormously. CloudFront at the edge. The account balance is disqualified on both counts. It is unique to one person, so no neighbor ever reuses it. And it must be exact, so stale is unacceptable. Shared and stable goes to the edge. Personal and precise stays home. So that is the Outpost. The very same idea you met back in the cache room, the copy kept close, now drawn across the whole globe. You made the copy fast, you kept it honest, and now you have pushed it close. And hold the through line. Distance is the one enemy no server can ever defeat. So you stop sending the question all the way to the answer, and you carry the answer to the reader's door. One breath to seal it. Latency is distance. You beat distance by moving the copy to the reader. A branch in every town. The branches are edge locations. The original is the origin. The whole network is a CDN, and in the cloud, it is CloudFront. Shared and stable goes to the edge. Personal and precise stays home. Close beats far.
That is the Content Delivery Network. Your library reopened in 100 towns at once, so no reader ever waits on the ocean. 13 rooms down. I'm Joshua. I'll see you in the next one.